Hey there, how's it going, everybody? My name is Nafalbek, and I'm a sophomore at Inan University in Tashkent. This is my project from Data Structures course. It's called Shortest Path from A to B. Let's move to the project quickly. If you were a tourist, you should have felt the importance of the map while you're traveling, right? If you're not, if you're traveling someday, you will absolutely feel the importance of the map in your travels, right? And imagine how many tourists got confused in the streets in the cities, right? And as the humanity is kind of pretty lazy, they always choose the shortest path. And yeah, of course, like there should be also kind of situations, maybe someone in a hurry, maybe someone is late into the airport, maybe someone late to the lectures, right? Uh, and if you talk about, there also should be mentioned that the ambulance is always in a hurry because in order to save someone's life, they have to find the shortest path from one destination to another. Let's talk about the operation. What kind of operation I've included in my application? So the main operation that was the best first search algorithm because it helps us to find the shortest path from one destination to another destination, as you can see on the graph here. And the second one was the queue. As we know, the breadth first search algorithm uses the queue as a main memory to store the all nodes in the graph. Uh, and the printing the maze was a function to kind of print the maze, right? In our case, it's map of the city, and is valid and find the end functions. Is valid function is for checking the is it going to the correct location or not, and so on. Let's take a quick look to the user input and output. As you can see here, it's kind of our maze. In our case, it's kind of city map. So O for the home, X for the hospital, Y for the shop, Z for the gym. And if the user wants to go to the hospital, it will find the shortest path to the hospital. And there is a directions of the down, down, right, 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 and so on, so on, so on. So, and if user wants to find the shortest path to the shop, they will find the shortest path to the shop. Yeah, kind of pretty useful, right? So let's talk about a quick choice of the data structure. As the BFS search algorithm beneath the graphical graph traversal, I have chosen it because, and there was a, I've chosen the adjacency matrix feature of the BFS algorithm because using program written in the two-dimensional array, and two-dimensional array stores as a matrix form, right? And as you can see here, it's a pseudocode of the algorithm. And of course, there was many algorithms to implement it, but I choose the BFS because it was a pretty easy one to implement in my program. And there are more algorithms like Aspect, Jurikas algorithm, BFS, and Bellman 4 algorithms to find the shortest path on the graph, right? Let's talk quick about the limitations and features of the algorithm. The BFS algorithm cannot handle the long path problems, and while the Jurikas algorithm can handle it, it can handle shortest path problems more quick. If the destination, as I said, if the destination is far from the current location, it consumes more time, and BFS search algorithm requires more space than it needs because it stores every node at the present level of the graph. And the time complexity of the BFS algorithm is always square when we use the adjacency metrics in our case. This makes it pretty slow. But the worst case is to the algorithm is you need to hold all nodes in the queue and it consumes more memory. So, and most giant companies not using BFS algorithm because, like in Google Map, they are use the Jurikas or Asterisk algorithm to find the shortest path problems because Jurikas, as I said, BFS cannot handle the long path problem. Yeah, and that's it. Thank you for your attention. Bye bye.